Hello everyone, welcome back to our food process engineering lecture series. In today's class, we are going to discuss one of the most widely used membrane separation techniques in the food industry known as microfiltration. Microfiltration is an important non-thermal separation process that helps to remove microorganisms, suspended solids, fat globules and other impurities without affecting the natural quality of the food. Because it operates at the low temperature, it is especially useful for processing of heat-sensitive products such as milk, fruit juices, beer and wine. By the end of this lecture, you will be understanding the principal working, membrane characteristics, factors affecting the process, industrial application, advantages and limitations of the microfiltration. So let us first understand what microfiltration actually means. Microfiltration, commonly abbreviated as MF, is a pressure-driven membrane separation process in which a membrane with pore size ranging from 0.1 to 10 micrometer is used to separate the suspended particles from the liquid. The membrane allows water, dissolved sugars, minerals, salt and other small molecules to pass through. However, larger particles such as bacteria, yeast, cells, molds, spores, fat globules and suspended solids are retained. So microfiltration is sometimes referred to as cold sterilization process because it significantly reduces the microbial load without using heat. This helps to maintain the natural flavor, color and natural quality of the food. So principles of microfiltration is based primarily on the size exclusion, also known as CV. A pressure difference is created across the membrane, generally between 0.1 and 2 bar. The feed solution flows tangentially across the membrane surface. Particles smaller than the membrane pores pass through and forms the perimeter. Larger particles that cannot pass through remains on the membrane surface and concentrate in the retenate. Unlike evaporation or distillation, there is no phase change involved. Therefore, the process consumes less energy and preserves heat-sensitive nutrients. The simple but effective principle make microfiltration highly valuable in modern food processing. So, we shall see about the factors affecting the next we shall see about the membrane characteristics of the microfiltration. So the three main properties of the membrane characteristics are pore size, permeability and material strength. So pore size controls the separation of the particles and permeability controls the flow rate of the solution, and last, material strength, which is directly proportional to the durability of the product, that is improves the durability. So common membrane materials are ceramic membranes and polymeric membranes. So here is the working principle of microfiltration. So initially, the feed liquid is pumped from the feed tank to the membrane module. As the pressure is applied, the liquid flows parallel to the membrane surface. So this is called cross-flow filtration, and this is mainly driven by flux equation, that is J is equal to Q by A. And the continuous flow minimize the membrane fouling by sweeping retained particles away from the membrane surface. Finally, the permeate is collected from further processing, while the retinate may either be recycled or used as a concentrate product. So here is the consideration of design of microfiltration. So it should be having high flux and back flushable, and high membrane area by to the volume ratio should be very low, which leads to pressure drop while maintaining high tangential velocity. So simple installation and continuous operation with minimum supervision can be done. So it also has low operating pressure and easy maintenance and simple membrane replacement. So it also has low energy consumption and relatively low capital cost. So here are some applications for microfiltration. And in this dairy processing, it is used to remove bacteria from milk and standardize milk composition. In fruit juice processing, it removes suspended particles and improves juice clarity. Beer and wine manufacturers use microfiltration to remove yeast cells. It is also widely used in drinking water treatment. Because it is non-thermal process, microfiltration helps to maintain product quality while improving the food safety. So To summarize, microfiltration is a membrane-based separation process that removes microorganisms and suspended solids using membrane with a pore size between 0.1 to 10 micrometers. Its working principle is based on size exclusion under low pressure. The major components include the feed tank, pump, membrane module, and permeate outlet, returnate outlet, and control system. It is major application include in dairy processing, juice clarification, beverage production, and water treatment. Overall, microfiltration is an efficient non-thermal technology that enhances the food safety. So, before we conclude, I would like you to think about the following questions. So, what does microfiltration called a cold sterilization process? What is the difference between the permeate and returnate? Why is cross flow filtration preferred over dead end filtration? Name the 3 dairy application of microfiltration. So thank you for your attention through today's lecture. In our next lecture, we shall study another important separation techniques known as ion exchange, which is extensively used for demineralization and water treatment in the food industry. So thank you and see you in the next session.